you. If we have time at the end of the lecture, I just want to look at the assignment with you. So it's good to start on time. So hopefully we'll have time at the end. We could look at the assignment. In today's lecture, we're going to look at the long run cost. But quickly, let me just remind you of what we covered last week. When we looked at the short run, first of all, we need to understand the difference between the short run and the long run. Okay? That's very, very important. And as you will see today, it's still relevant. So without understanding the difference between the short run and the long run, it's going to be difficult to pick up the idea of the main idea of this lecture. So let me just go back to what we said last week. We said for a firm, there are sort of decisions they can make in the short run, and there are different kind of decisions they make in the long run. Basically, we looked at, if you're looking at the time frame in which we can, or we have fixed inputs, then this is a short run. Okay? So we have some of the inputs that we cannot change, then we are in the short run. If you're able to change all inputs, then we move to the long run. And that's what we're going to see today. Okay? So going back to what we said last week. Last week, we looked basically at the short run. And if we assume we have two inputs, labor and capital, then labor was the variable input, the input that you can't change in the short run, and capital was the fixed input that you can't change in the short run. Okay? In the long run, as you'll see today, we will be able to change both. And we'll see what sort of decisions we need to make in the long run. But in the short run, what we discussed last week, we always were looking at, we looked at what or how many workers we should hire or should employ, given the amount of capital we had. So if we had 2 machines, 3 machines, so that was given. So it's something that we cannot change in this time frame, the short run. And that's why we were looking at what will happen to the output and to the cost when we change the number of workers employed. We looked at both. We looked at the output side and the cost side. With the output side, we looked at 3 concepts: total product, marginal product, and average product. Okay? With the cost, we looked at the total cost, the marginal cost, and the average cost. And since we have fixed inputs, which is capital in this case, or typically we assume is capital, we have fixed cost and variable costs. Okay? So the fixed costs come from the input that you can't change in this time frame, in this short run. And the variable cost comes from the amount of workers you hire. Okay? So we looked at how these, or the relationship between these in the short run. We saw how the marginal product curve cuts the average product curve when the average product is at the maximum point. And on the other side, we looked at how the marginal cost curve cuts the average cost curve when the average cost is at the minimum point. So when we look at the cost, we make this distinction, or we saw how the total cost could be split to 2 components: total fixed cost and total variable cost. So the total fixed cost is not related to the output level. So if you produce nothing, you're still paying the total fixed cost. If you increase your output, well, you pay the same. So it's not going to change. And that's why you see the curve, the total fixed cost curve is a horizontal line, because it doesn't change when you change the output level, which we measure on the horizontal axis. So it doesn't change. That's why it's total fixed cost. That's why it's fixed. Okay? Remember, that happens in the short run, not in the long run. So in the long run, all inputs are variable. So there is no fixed cost. So all are variable. And also, so the total cost is the total fixed cost and the total variable cost. And we saw how the total variable cost starts from the origin point, start from 0. Because if you produce nothing, then you hire no workers, then it's 0. It's not going to cost you anything. You're not paying salaries to anyone. You basically have no workers. Okay? So to increase output, given that capital is fixed, you can't change the number of machines you have, for example. Then to increase output, then I need to hire more workers. Okay? And then that means I pay them. So that will increase the variable cost. And that's why the variable cost starts from the 0 point, from the origin point. Okay? The total cost, which is the sum of these two, start from, not from 0, from a positive, like from the, where the total fixed cost cut the vertical axis, because the minimum you will have or you will pay as a cost is the total fixed cost, even if you produce nothing. Because you already bought the machines, you paid for these machines. Okay? So that's why the total cost starts from a positive number. So because you already, the minimum is the total fixed cost, and the total cost is just start from there. So it doesn't start from 0. That's the total cost. When we look at the average cost, we did the same. We looked at the average total cost is two components, the average variable cost, and the average fixed cost. Okay? So the average fixed cost is also declining, so it's decreasing when you increase the output, while the average variable cost takes a U-shaped curve. So it looks like that. Okay? So when you increase output, first it declines or decreases, and then come to the minimum point, and then it increases again. So it takes this U-shaped curve. That's the average variable cost. The average total cost, which is the sum of these two, the average fixed cost and the average variable cost, it takes the U-shape, the same U-shape, but above these two, because it's the sum of both of them. And the distance between the average total cost and the average variable cost should equal the average fixed cost. What we saw also is the marginal cost curve, how the marginal cost curve cut these two, the average total cost and the average variable cost, when they become at the minimum points. Okay? So that's all what we covered last week. So that's pretty much everything we discussed last week. And that was the short run. Again, going back to the same point. So what's the short run? It's a time frame in which we have fixed inputs, or some inputs that are fixed, that we can't change. Okay? That's a short run. So we looked at the output and the cost in the short run. Today, we will look at these in the long run. So now we understand, if we're looking at the long run, we understand that all inputs are variable. Yes. So we change everything. We could change the number of machines. We could change the number of workers we hire. Okay? So it's very important to understand the difference between the short run and the long run, and hopefully now you understand this, and we will see today how to explain and drive the firm's long run average cost curve. So in the long run, how the average cost curve will look like. So let's start, as I said, in the long run, we understand all inputs are variable and all costs are variable. So we don't have fixed costs. Okay? Because all inputs are variable. So all inputs are variable in the sense that you can change them. So you can change, you're making decision, now your decision can include the number of machines you have and the number of workers you employ. So you can decide in both. In the short run, you will not able to decide or to change the number of machines. We could only change the number of workers. Okay? So now in the long run, we can change everything. So we can change all inputs. And the way the long run cost will behave will depend on the firm's production function. So what is the production function? Basically, this is the relationship between the output and the quantities of capital and labor we employ. Okay? So the output, how many units we produce, given that the quantities we use from labor and capital. These are our inputs. Now there is nothing fixed, yeah? So they both are variable. So I can't change labor and I can't change capital. So let's see an example now. So we have an example here in the long run. As you can see, these are the outputs, the number of sweaters per day. And on the first column, in the first column here, we have labor. This is the number of workers per day. So we could have 1, 2, 3, 4, or 5 workers. These columns here tell you how many machines we have. So these are the knitting machines. So that's the number. So plant 1 has 1 machine. Plant 2 has 2 machines. Plant 3 has 3 machines. Plant 4 has 4 machines. So the decision we're trying to make here, or what we can do now in the long run, which plant size, so you can't change the plant size. You can look at the, you could have 1 machine and change, like see how many workers you employ, the same thing, or you could, so you could change both. That's the point. So you could change machines and the number of workers you employ. So you see, so the difference now here is that we don't take capital as given. It's something that we can change as well. So if we look at this, for, let's say, if we have three workers per day, and for plant 1, this will give us 13 sweaters per day. So that's the output level. Okay? If we have 3 workers and 1 machine. So when you increase the machines now, or we increase the plant size, okay, it's very simple here in this example because we increase the plant size by 1 machine. So we increase only, we look at 1 more machine. So we have 1 more. So we're looking at labor now. We assume like we're looking at only 3 workers, and then we see what happened when we increase the number of machines. So you see we have 18 sweaters per day. If we look at plant 3, we have 22, and plant 4 we have 24. So the question now, which plant size or which plant of these you should choose? Okay, we'll know now. We'll know today which one we should choose. What is the ultimate goal for any business or any firm? What they were trying to achieve? Maximize profit. So that would be the target. That's what we're trying to do. So that which will determine which plant we should look at. Is it plant 1, plant 2, plant 3, plant 4, and so on. It depends how many units we want or how many sweaters we want to produce per day. So if we look at this vertically, so if we look at this the same way we looked at it before. So for example, if we have only 2 machines, which means we're looking at plant 2, then you see when you increase the number of workers from 1 to 2, the output will increase from 10 to 15. You get the 3rd worker, then the output will increase to 18. The same thing again. So the idea here is then, what about the marginal product of labor? That's something we covered last week. So what's happening here to the marginal product of labor? So what's the marginal product of labor first of all? Okay? Do you remember? So the marginal product, so it's the change in the total product. Okay? So changing the total product, because I'm looking at the marginal product of labor, then is when you change the total, the change in the total product, okay, or the change in the output when you increase the workers by 1. So when you employ 1 more worker. So let's look at what happened here. So if we increase this from 1 to, so first of all, the first worker with 2 machines give us 10 units, 10 sweaters per day. What about the, when we add another 1, 2, so we have 2 workers now, what's the total output? Is 15. So the total output increases. Okay? But what about the contribution of the second one? So the first one give us 10 sweaters per day. Okay? When we added the second, that's the first one. When we added the second one, so the contribution here is the marginal product of this second worker. So how much they added? 5. So that's the change in the total product. Yeah. So what we have here is 5. So the contribution of the first one was 10, and then the contribution of the second one is 5. Let's see the contribution of the third one. 3. So what's happening here to the marginal product of labor? It's diminishing. Yeah, it's decreasing. Okay. So let's look at the same. Look at the marginal product of capital. So how to look at this? Let's look at this if we have only 3 workers. So 3 workers, we have the first machine, we got 13 sweaters per day. And when we added 1 more machine, so we move to plant 2, why we can do this? It's the long run, exactly. So that's the long run. So I can't change capital as well. So that's why I could look horizontally or could look this way. So you see, so the contribution in the first machine was 13 sweaters per day. And now when we change this, when we increase 1 more machine, so when we have the 2 machines now, we had the total output is 18, which means the second one contributed by how much? Exactly 5 sweaters per day. So this is the marginal product of capital. Okay, so what happened here? So the first one was 13, then 5. Then what about the third one? From 18 to 22, when we added the third machine. 4. So again, so 13, 5, 4. So what's happening to the marginal product of labor? Is again diminishing. So it's the same. Okay? So how we look at the marginal product now? We assume that the other inputs are the same. So when we looked at the marginal product of labor, we assume that capital is the same. So we looked only at when we have 2 machines. If you want to understand the marginal product of capital, then we need to assume that we're not going to change labor and see what will happen when we add more capital or more machines. Okay, and in both in these cases, in both cases, we have diminishing returns, and that's why you see the marginal product is declining. Okay, this will take us to this concept is the marginal product of capital. We already covered the marginal product of labor last lecture, so it's the same concept. So we're looking at the marginal product of capital. Then what is the marginal product of capital? This is the increase in output resulting from a 1 unit increase in the amount of capital employed. So in our example, 1 more machine. Okay? Holding constant the amount of labor employed. So we hold the other input constant and see how much this machine or 1 extra machine will add to the output. That is the marginal product of capital. And we already saw the marginal product of labor from last week, and in this lecture again, so it's diminishing as well. So what we have here, we have diminishing marginal return to labor for a given plant. So if we assume that we don't change capital and we change labor, we'll see we have diminishing marginal return. The same thing with capital. So we have diminishing marginal returns to capital for a quantity of labor. So if you assume that we're not changing labor. I understand that in the long run we change both. We can't change both. Okay? But for this reason, we will have the U-shaped curves for the cost curves, like the same way we looked at in the last lecture. Okay? So, for example, if we have two machines, and we're looking at certain like plant, so we're looking at here like plant 2, for example, and you increase labor, you increase the number of workers you employ, what will happen? Because we have diminishing marginal product, that cause the cost curves to take this U shape. So as I said, when you increase output, first or initially, the average cost, for example, decreases, and then come to the minimum point, and then if you increase output level out after this, the cost will start increasing. So you have this U-shaped curve. The same thing with the average total cost, the average variable cost, and the marginal cost. We know this from last week. So they take this U shape. So what we could have here, we could look at each one of those plants and think of, okay, how the cost curve will look like for each one of those. That will be the same we covered last week, because now we're looking at, we're not changing capital, we're looking at, for one machine, if I change the number of workers, how this is gonna shape the cost curve. Is gonna take the U shape. Okay? So let's see, for example, here. If we, let's look at we have different 4 plants. Let's look at the curves. So let's look at the first one. So now, if we have plant 1, so plant 1 here means that we have only one machine, and you change the number of workers. How the average total cost curve will look like, it will have the U shape. So that's the normal one. That's the one that we covered in the last lecture. Okay? So now, if we have 2 machines, if we look at plant 2, so if we have plant 2, this will give us another U-shaped average total cost curve. Okay? So the first curve, just imagine this is as if we were in the short run. Okay? What we had fixed amount of capital. We didn't change, which for plant 1, we have only one machine. And as you increase the labor you hire, the marginal product of labor will be decreasing, and that's why we have like diminishing return to labor, and that's why we have this U-shaped average cost curve. So if we do this for each one of those plants, okay, we will have a set of, let's say, short-run cost curves. That's what we had last week, okay? So for the third one, for example, we have this one. So this is the average cost curve for plant 2, for plant 3. The same thing if we look at, remember, plant 1, 1 machine, plant 2, 2 machines, and so on. The plant 3, 3 machines, plant 4, 4 machines. So for plant 4, where we have 4 machines, then we have a very similar, again, average cost curve. So we have 4 machines, and we change the number of labor, and because we have diminishing return to labor, that's why we have the U-shaped curve for these cost curves. Okay, so, but we are not in the short run. We are in the long run. So these are different decisions, yeah? But we still want to think in the long run. We can't change the plant size. We can't do that now. We can decide which one to choose. Is it plant 1, or 2, or 3, or 4? Okay? So what we're trying to do here, we're trying to maximize profit. Then we try to minimize the cost. You're trying to look at the minimum cost. And from this, you could drive what we're going to call the long run average cost curve. The long run average cost curve. So we care about the average cost, but in the long run. And given that I can change all inputs, then it can't be higher than any point here. So it should be the minimum point. It should be the least cost. And that is what we are interested in the long run. So in the long run, we're trying to understand how can we we drive this long run average cost curve. So the difference, again, we can change the size of the plant, or we can change the plant size, we can change the capital and labor. So the long run average cost curve basically is made up from the lowest point on the average total cost for each output level. So going back to this, so if you want to produce here like 10 units, so that is the minimum. You see, if you want to produce this, so the minimum will be on plant 2. If you want to produce 20, the minimum is more likely to be here, yeah? So that's the least cost. So basically, in the long run, because you could change the plant size, you could decide which plant actually, how many machines you could employ or hire. Okay? So you're choosing between not just the number of workers, the number of labor, you choose also between how many machines you should have. So in the long run, as I said, because we're trying to maximize profit, then it can't be higher than any of these short-run cost curves. So it must be the lowest one. So we're looking at the least cost. And that makes sense. If you want to maximize your profit, then that means you want to find the way for each one of these, or for each output level, you try and see which plant size will minimize the cost. Okay? So, as I said, and from this point, if we can connect these points, given the options we have 4 plant size to choose from. So we have 4 types of plant or number of machines from 1, 2, 3, and 4. Then if you connect these together, then you could have what we call the long run average cost curve. So it's very important then to look at each output level and see which plant will give you the lowest cost to produce that. Because it's rational. If it's not rational, if you choose something different, then you need to look at, if I want to produce 10 units, which plant size will give me this? If I want to produce 15, which plant size will give me the least cost? And so on. So will give me this 10 units, 10 sweaters per day, and minimize the cost in the same time. So, for example here, if we want to produce 13 sweaters per day, which plant size we should choose? So of course, we agree that we want to choose the least cost way of producing these 13 sweaters per day. So let's look at this again. So 13 is here. If I choose plant 1, so how much is the cost? Is 7.69. Okay? If you choose plant 1. So if I choose plant 2, so then that's the average total cost curve for plant 2, the green one. How much is the cost? Is 6.80. What about the third one, plant 3? Plant 3 is this purple. Yeah, it's the same. So it's 7 is the same as the first one. So it's 7.69. What about the fourth one, which is the red one, the red curve here? You see? So to produce 13 sweaters a day, this, and if you choose plant 4, this will cost you 9.5. So which one you choose then? Exactly. Plant 2, isn't it? The green one is plant 2. That is the plant size that will minimize the cost. You have this, because you're on the long run, so you can't choose which plant size. Okay? And now, for each output level, there will be one of these plant size will give you the minimum, will give you the output, this output, at the least cost or the minimum cost. Okay? So what we're trying to minimize the cost if you want to maximize your profit. So that make it very clear now. So the least cost way of producing 13 sweaters a day is using 2 knitting machines, which is plant 2, the green, this point, which will cost us 6.8. Okay, so if we think that way, then for each output level, we could find that minimum point, and then we connect these, or the least cost, and we connect these together, given the different sizes we choose from, 1, 2, 3, 4, and this will give us, or this should give us, what we call the long run average cost curve. So the long run average cost curve then is the relationship between the lowest attainable average total cost. You see, we will looking at the average total cost curve. So we're looking at the minimum or the lowest point, and output when both plant and labor, so capital and labor are valued. So you can choose, you can change everything. And also you can choose, or you can use this as a planning curve that tells you how to minimize the cost of producing a given output. So the same way when we looked at 13 sweaters a day, by looking at this average, long run average cost, we could tell which plant size, or how to minimize, or how to produce this at the least cost. Okay, so let's look at, these are the 4 plants we have, 1, 2, 3, and 4. And now, given that we understand now, the long run average cost curve is for each output level, we look at the least cost. So let's look at the first one. So from 0 to 10, which one will give us the least cost? Exactly. So that's plant 1. You see that? That is, compared to the other, this is the least cost. So for this range, from 10 to 18, you'll see plant 2, which is this green, from this point to this point, you see this is the least cost. Okay? And for this range, from 18, for example, to 24, you will see that this purple one, plant 3, giving us the least cost. And for this range, you'll see plant 4 giving us the least cost. So that's exactly the long run average cost curve. So if you connect these together, this will give us the long run average cost curve. So let's connect these together. Now we have the long run average cost curve. So do you understand now the idea behind the long run average cost curve? So if you have different plant sizes and you want to choose which one, so you look at each output level and see which plant size will give you this at the least cost. And that makes sense, yeah? So as we saw with the case of 13 sweaters a day, plant 2 is the plant size that will give us this at the least cost. Is this clear? Okay, it's good. So that's now like mostly everything we have today. So that if you understand the long run average cost curve, that is the important thing today. That's the message you need to take away. How we drive this long run average cost curve. Okay? So given that you understand in the long run, we can change both. We can change all inputs. So we can change labor and we can change capital as well. Okay? Okay. So now we have the long run average cost curve, and that's the important thing. But if you see the long run average cost curve, it takes this similar shape, this U shape. So what you see now, first, when you increase output, what happened to the average cost in the long run? It's decreasing. Okay? And then, after a certain point, if you increase output again, so you see, it's decreasing here, while you're increasing output, or if you increase, as you increase output level, moving this direction, then you'll see this blue line here, which is the highlighted one, the long run average cost curve is just declining, so it's decreasing. At some point, and then after this point, as you increase output, what happened to the average cost? the long run, it increases. So it takes very similar shape, like this U-shaped curve. Okay? But it's important to understand how we drive this one. So the first part of the curve, this, where if you change or if you increase output, or as you increase output, the average cost curve is declining or is decreasing, that is called economies of scale. So which means it's better to increase. When you increase the output level, you actually going down on the average cost curve. Okay? So you decrease actually the average cost is declining. Okay? But after this point, what happens if you increase output level? The average cost start increasing. And this is diseconomies of scale. Okay? And that's what we're looking at now. So economies of scale and diseconomies of scale. So economies of scale, this is a feature of firms' technology that lead to falling the long run average cost curve as output increase. So when you increase output, you see what happened? The first part of the long run average cost curve is decreasing. The second part of it, which is when you increase the output, the average cost in the long run will increase. This is called diseconomies of scale. So if in the middle, if at some point, when you increase output level, you have constant long run average cost curve, so it's like horizontal for some time or some point, then this is constant returns to scale. So I have these three different stages now. So economies of scale. So you see the long run average cost curve, you're moving down on the long run average cost curve. Okay? While as you increase the output. So let's go back to the graph. Oh, this one, sorry. Yeah, this one. So you see the blue one here is the long run average cost curve. So you see what happened here? That is this point, so this range from 0 to 15, we have economies of scale. Why? Because as we increase output, the average cost curve is decreasing. After this point, which is 15 here, you see, this economies of scale, because as you increase output, the long run average cost is increasing. Okay? So if you have some point where this will be constant return to scale. Okay? So this will take us to the last point, which is the minimum efficient scale. The minimum efficient scale here is where we want to be. Which point here on this curve? So that is the point where you actually, or this is the output level where you will have the cost in the long run at the minimum point. So where's this here? When you produce 15 units. So if you produce 15 sweaters per day, which plant size will choose? That too. Yes, exactly. It's on this too. But that means you should choose plant 2, and this point here will minimize the long run average cost compared to all other output levels. So comparing this to any other level here, 15 will give us, with plant 2, that will give us the minimum cost in the long run. And this is the minimum efficient scale. So the minimum efficient scale, that's what we already explained now. So it's the quantity of output, which is 15 in our case, which the long run average cost reach its lowest level. So that is the minimum point on the long run average cost curve. That is the minimum efficient scale. And as we saw, if the long run average cost curve look like U-shaped curve, then the minimum point identifies the minimum efficient scale output level. So on this graph here, where is it? Exactly here. So this is at 15. So 15 sweaters per day, that give us the minimum the minimum efficient scale. Okay? Any question? So let's just sum up what we did so far. So because this is pretty much everything we want to cover today. So first, we talked about the difference between the short run and the long run. I know I repeated this again because it's very important. So the short run, we have fixed inputs, but in the long run, all inputs are variable. So in the short run, we have fixed inputs and variable inputs. But in the long run, we can change everything. So all inputs are variable. When we looked at the short run, we saw these U-shaped cost curves. So that's something we covered last week. Today, the important point or the message you need to take away with you is how to drive the long run average cost curve. So at each output level, we looked at which plant size will give us the least, or this output at the least cost. If you connect these together, this will give you the long run average cost curve. And when we look at the long run average cost curve, you will see these two stages, or even could be three. So economies of scale, which means as you increase output, the average cost is decreasing. And diseconomies of scale, as you increase output, the average cost is increasing. And if you had at some point it was constant, this is constant return to scale. And the last one, which is the minimum efficient scale, is the lowest point, or the output that will give us the lowest point on the average cost curve. Okay? So that's all what we wanted to cover in this lecture. Do you have any questions? We have some time to talk about the assignment, but do you have any question before I move to the assignment? Do you want to go? I want to talk about the assignment for 2-3 minutes, if you don't mind. You don't want? Do you want a break, or we want to look at the assignment? Assignment, then be quiet, please. Okay, assignment, that's fine. Okay, so let's look at the assignment. So the assignment, we know now I hope now that everyone knows that we have only one assignment, because I still receive emails asking me about the first assignment and the second assignment. We have only one assignment, okay? And this assignment, we have 3 questions. The first 2 questions, you should be able to answer them after week 2. So you don't need to wait until the last minute. So you should be able to answer question 1 and question 2. Question 3, in the next lecture, we will cover perfect competition. The week after, next week, we'll cover monopoly, and that will be the last lecture on microeconomics. That means, hopefully, if we cover everything we need to cover this lecture and the next lecture, hopefully next week we'll start macroeconomics. That means probably before the end of this month, probably at the 3rd week, you should be able to answer, hopefully, question 3. So that's the idea. So my idea is, don't wait until the last minute to answer the assignment. Because what you need to answer, what we didn't cover, is question 3. So you should be able, if you have question 1 and 2 ready, then you don't need much time to answer question 3. And then you will be ready to submit your assignment on time. Okay, so if looking at the assignment very quickly, question 1, show you the demand and supply schedules for potato chips. So we have we have price, quantity demanded, and quantity supplied. Okay? So there are different situations here. First, you need to tell me the equilibrium price and equilibrium quantity and explain your answer. So you see, you should use graphs, not just telling me. So the question is very clear. Using appropriate graphs, answer the following questions. So you need, with the aid of graphs, to tell me and show me the equilibrium point. That means I need to draw the demand curve and the supply curve and see where they intersect. That's the equilibrium point. So where's the price and the quantity at that point, and this is the equilibrium. And you need to tell me why this is an equilibrium point. Okay? That's very, very important to understand why is it an equilibrium point. Why is this is the equilibrium point. And then if a new snack food comes into the market, how this is going to affect the demand. Oh, it's already actually tells you. So as a result of this, we have the demand for potato chips decreases by 40 million. So what happened? So it is very clear. So which curve will be affected by this? Demand or supply? Demand. Okay? So you need to tell me where the new equilibrium point will be. Okay? You need to draw it. You could see it. You could easily, looking at the quantities here, the quantity demand at each price. So it's very straightforward to tell the new quantity demand. Okay? The same thing with the next question. So I don't think this question has any issues or any problem to. It's very straightforward. So if you understand how to draw demand curve and supply curve and what we mean by equilibrium, then when the demand change, it's very easy to find the new equilibrium point, because again it will be the intersection point between demand curve and supply curve. So is nothing. I mean, there's no problem about this. The same thing with the second question. So I hope if you so basically if you do A and you understand how any change happen here will affect demand curve and the supply curve, then it's very easy to find the new equilibrium point. So always see how this change gonna affect your demand curve or your supply curve depending on the impact. So in B, for example, is obvious, like telling you that this will decrease demand. So that means at each price the quantity demand will drop, and it tells you by how much. Okay, so you can construct the new demand curve, and then look here, see which or where the equilibrium point is. Okay, I don't want to talk more about this. So that's the idea, and the third one is the same. Or C is the same one. So with with question 2, it's about elasticity, and you have the demand curve for pens. And the question is to calculate the elasticity of demand for a rise in price from $2 to $4. Okay? And then, so that's one part of the question. And then, tell me at what prices the elasticity of demand equal to 1, greater than 1, and less than 1. So let's look at the first part. So the first part of the question is very straightforward. If you can calculate the elasticity. So elasticity percent change in the quantity divided by the percent change in the price. Some of you already told me, okay, I mean in the lecture, we did it by looking at when we divide the change in the quantity by the average quantity. Some of you said, well, we used to do this by looking at the original quantity. I'll make a short video to explain the difference. And as I said before, is if you move from A to B, this will give you a different answer from B if you move from B to A on the same curve. I'll explain this in more detail, so don't worry about that. So calculate the elasticity the way you understand it, that's fine. If you want to use the average quantity and the average price the way we did it in the lecture, that's fine. If you want to do it the way you used to, just tell me that you use the original quantity and the original price. So just show me you understand what you did. And because it's very clear here, we move from 2 to 4, so it's very easy to tell which one is the original price and which one is the original quantity. Again, if you want to know the original quantity, obviously you need to get this from the graph. Okay, it's the change in the quantity, sorry, not just the original quantity. Anyway, so looking at the second part, which I received many questions about. So if we look at the lecture we did in elasticity, when you have a demand curve, okay, so when you have this linear demand curve, this straight line, okay, so we looked at 3 parts on this demand curve. So on the top part, and we explained why it is elastic, and in the middle why it is equal to 1, and then why it is less than 1, and the bottom part of it. So my point is the only thing you need to identify is where these are. So where it is equal to 1, where it is more than 1, where it is less than 1. So again, I'm not going to say more about this, but it's again, go back to the lecture. The lecture is on YouTube, and you will see this point. So the rest of this question is very straightforward if you can calculate elasticity. So if you can calculate elasticity, the price elasticity, we know this, the percent change in quantity divided by the percent change in price. The second question is looking at, I think, is it income elasticity or... Oh, this is cross elasticity. The cross elasticity, then again, so it's the percent change in the quantity of one product divided by the percent change in the price on the other product, and then the sign is meaningful. The sign will tell you the relationship between these two products. Go back to the lecture, and this will be very clear. The last one, I think it's the same way. So again, it's income elasticity. So income elasticity, percent change in quantity divided by percent change in income. So please go back to we did a tutorial, we did a seminar on elasticity, how to calculate elasticity. We did the lecture. So go back to the question we did in the seminar, go back to the examples we covered in the lecture, and that should be very straightforward. And please finish question 1 and question 2 as soon as you can, because probably you will have maybe a week to do question 3 or maybe less. So just do question 1 and 2. Hopefully we'll finish microeconomics by the next week, and we'll start macroeconomics by the second lecture in the next week.